So today's session is on web app hacking. No Harlan or Michael this week. He's stuck with me. So what's on the agenda for today? So we have an intro to web apps, SQL injection, cross-site scripting, other types of attacks, useful tips and tools, and some resources. So standard disclaimer. Anything we teach you is for educational purposes only. We don't condone nor do we tolerate any behaviour which violates university regulations or the law. So what this means for you is unless you have explicit written permission to attack a web app or any infrastructure or anything in general, you do not do it. It's a breach of the Computer Misuse Act. Sorry, SQL gaming. Um, so yeah, if we become aware that you've been violating our code of conduct or this disclaimer, you may be expelled from the society, reported to the university, or in some cases the police if what you've done is bad enough. There's more information on our code of conduct. You might think it's not necessary, but you know, stuff like this is dangerous in the wrong hands. So before we can start attacking a web app, we need to understand how web apps work. So a web app is essentially it's just a piece of application software that runs on a web server. You can access it through a web browser normally, and the way they are structured is generally client server. So you, the client, will request the web app from the server. Typically, we will build them with a web service stack. So LAMP, for example, which is Linux, Apache, MySQL, and PHP. We all have our own views on PHP, but um, yeah, it's quite ubiquitous in the real world. You'll see a lot of this still, but a lot of web apps are moving to JavaScript based frameworks. So Mean or Mern, which is Mongo, Express, Angular or React, and Node. So MongoDB. So typically we'll use a relational database, which is where you have obviously your primary and foreign keys. But MongoDB isn't a relational database. It's a I forget what they're called, but it's not, and it can scale up quite efficiently, which is why they're starting to be used now. So today we'll primarily be concerning ourselves with the logic layer and the storage layer, but each layer obviously introduces its own unique different vulnerabilities. So now you know roughly how a web app works. How do we go about attacking them? So really it's more of an art than a science. So obviously web apps are made by people. People have their own logic. Um, their logic might be different to yours. It might not make sense to you, but there was a logic behind their decision making. So really, when we try to attack a web app, we sort of have to understand this logic and try and see it from their perspective. So something that is happening all across, computing in general and IT is everything is becoming increasingly complex. So what this means is when we try to attack a web app, previously we'd have something like one static page, maybe some other random, like a search box or something. But these days you have a wide variety of different places that you can go about attacking. So whilst this makes your attacks more complex and requires a greater depth and breadth of knowledge, it also means that it's easier to find different attack paths. Um, so vulnerabilities really exist across layers and on both the client and server side. It's not limited to one single place. So, for example, on the storage layer, we've got SQL injection, which we'll be covering today. Uh, we've got Apache web server vulnerabilities, command injection, which sort of goes from the logic layer down to the operating system. We've got client and server side request forgery, which is essentially getting a client or a server to produce a request it normally wouldn't. We've got server side template injection. This is where, so Some web frameworks are template based, which means they use templates to dynamically generate websites. So what we can do is we can inject template like code or directives, it's called. It's sort of like a command for the template, and this will be rendered back to the user. We've got insecure direct objects reference, which is where we sort of tell a web server to give us a file, but we tell it at such a low level that it doesn't actually bother checking anything, it just trusts it. Deserialization, so some frameworks are now starting to serialize data when they transfer it. So when we have an insecure deserialization, we can submit some malicious piece of data, and when it's deserialized on the server side, it will be executed. Obviously, that's bad because we can pass in commands and stuff like that. And there's many, many more. Web app hacking and attacking web apps is a massive field. So I think before we cover SQL injection, we should probably go over a quick little, SQL primer. So really, SQL, SQL, however you want to pronounce it, structured query language. It's a language which is designed to sort of retrieve information from databases. Every vendor has their own implementation of SQL. The syntax can vary very slightly, but the general principles behind SQL are the same. Primarily, we will use it to query databases, but it's actually possible to do so much more with it. So when we think of a SQL query, it's essentially just a line of code that's asking the database for more information. So if I wanted to get the names of all the users, I can ask the database to give me back all the users in a certain table. And as you'll see from the examples below, it's quite intuitive and high level. So we won't be explaining today in full detail how to structure a query. For those of you doing computer science, unless 107's changed, you'll be having fun with that this year. And next year, you've got a databases module as well. So some common statements include the select statement, which is where we select or get data from the database, and we get it from a table where certain conditions are satisfied. So if we look on the table on the right, so here we'd be selecting all the users from the users table, this table, where the ID is 12. So we'd be getting John Doe back. So if we wanted to insert a value into the table, we can insert the value with the following field. So we'd be putting Harlan Connor into the database. We can also delete users from the database. So we could delete Harlan from the database. So what this is here, it's hard to see it because of the PowerPoint formatting, but that's 2 dashes, and that is essentially just a comment in SQL. So if you see that in the future, that's what that is. So what is SQL injection? It's essentially just a code injection attack using the SQL query. So normally we'll use it to just extract some data, dump the tables or the table names. But it actually, it can sort of get a lot worse than that. We can perform denial of service attacks on a database, escalate privileges once we've compromised the database, or actually, oftentimes databases run with slightly higher privileges than normal, and this can sometimes lead to complete compromise of the underlying system. So there are multiple ways to perform SQL injection, and these vary. These vary in complexity, but we'll cover that a bit more later. And yes, I did steal this from Comp 207, but it is relevant. So you're probably wondering how we can perform SQL injection. So quite often, when we're querying a database, we need some kind of user input to complete the query. So, for example, say we're trying to get the IDs out of a table. So we can query the table. We want to get the ID from the users table where, we're given a certain username and password, which we can get. So normally you would supply a username and password, like Harlan Hunter2, for example, and the query would then be complete and go and get the ID back and give it to you. But what if we supplied the wrong password? obviously, if you supply the wrong password, it wouldn't give you the ID back. But what if we added some SQL to the password instead? So here in this, sample user input, we give them the user Harlan, but we also give them the wrong password and some SQL. So what this SQL does, it evaluates to wrong password or 1 equals 1, which will evaluate to true. So essentially, all these quotation marks are doing is sort of escaping one another. And what this ends up as is literally just 1 equals 1, which evaluates to true and will actually return all the IDs from that given database. So here's a different but fairly similar example. So imagine we have a simple login system where we're posting the username and password. The query will look something like this, as we saw earlier, where the user name and password that we supplied is passed into the query and ran against the database. So if we were to try and log in as Harlan, it would look something like this if we supplied it with a normal username and password. But what about the wrong password? It won't log you in. But what about if we use SQL injection to just bypass that altogether? So if we supply the payload Harlan, end quote, and then a comment in SQL, this will sort of... So SQL evaluates things in a weird way. So this might not make sense to you, but essentially it's closing it and opening it again. But the comment is sort of breaking it up and having it close in a weird way and open in a weird way. But essentially, all this evaluates to is Harlan and 1 equals 1, which will log us in. It seems really simple, and in the past, payloads would actually look something like this, or that standard, or 1 equals 1 payload that you see if you Google SQL injection. Nowadays, web frameworks sort of have, and when you're querying a database, it sort of has the protection built in and you have to override it. But I know from personal experience in industry, legacy applications are still vulnerable to attacks like this. Back when they were first implemented, they didn't, parameterize queries or anything like that. And they just passed the untrusted user input straight to the query. So you will still see stuff like this, even if you think it's beyond, simple these days. So there are 3 main types of SQL injection. So we have in-band, which is the most common and the most easy to exploit. This is where we're sort of in the same channel as the database. And so imagine you're just searching for a product on a website. This would be in-band SQL injection because the result of your sort of injected query is returned back to you in the HTTP response and displayed on the web page. So there's 2 main types of injection here for in-band. We have error-based SQL injection. This is where you sort of try to force the database to give you an error back. So what this can do is, in the error message, it can give you information about the structure of the database. And quite often, if you have a successful injection, the data you've extracted from the database will be returned in your error. You also have union-based SQL. So something I didn't talk about earlier was the union operator. This is essentially, so if you wanted to query 2 different tables, but output them in the same query, you would use a union operator. So what this does is it essentially combines 2 queries together into a single statement. So here we could just, send a normal database query, like, how a normal user would, but we can use a union statement to join up our malicious query. And this will then give you back the results of your normal query, but also the results of the malicious one. So something which is a lot harder to exploit is blind SQL injection. And this is where an attacker really works out the structure of a database by inferring it based on the behavior that they observe. So there's two main types of this: Boolean and time-based. So Boolean-based is where we want our query to evaluate to true or false. If it's false, it won't sort of give you any results back or have any implication on the web app. If it's true, it might make a change in the web app, and we can infer that the query is true or false based on this behavior. Time based is where we ask the database. So for those of you familiar with Python, there's a function called time.sleep, which essentially pauses execution for like a few seconds. This also exists on databases, and this is what time-based SQL injection is. We can sort of ask the database to sleep or pause execution for a few seconds. And if we see this behavior like reflected in the website, so it carries on loading for a few seconds, then we know that our query has been executed. If it just loads instantly, we know it's not been successful. Another really a lot less common type of SQL injection is out of band. So this is where, say you have a really dodgy server, the responses are constantly changing or it's constantly going up and down. We can query a database and have it give us back the answer over DNS or HTTP. It's a lot less common because a lot of databases either have this functionality turned off or just basically don't support it. So obviously it's not very common, it's very hard to exploit, and it's not something you'll really see in the wild. I don't think I've ever seen it happen in the wild at all. So, SQL injection sounds really bad. It can be really bad, but luckily we can prevent it. So in the majority of cases, it can simply just be prevented using parameterized queries or prepared statements, as you might also know them. So what a prepared statement does is, instead of blindly trusting and concatenating user input, it will sort of just take care of, sanitizing the input so that no sort of SQL is injected into the query. So if you look at the following code, the first line of this code, it's vulnerable to SQL injection because we're just directly concatenating the input onto the query. Whereas if we do something like this with a prepared statement, it will sanitize your query for you and then add it on as necessary. Personally, I feel like this is a lot easier anyway. But if you look at older tutorials, it will probably just tell you to do this. But thankfully, in a lot of modern frameworks, it comes as standard to use prepared statements. So the next thing we're going to talk about is cross-site scripting. Essentially, when you interact with a modern website that's running JavaScript, it's executing a lot of different scripts constantly. So really, it's a vulnerability by injecting malicious JavaScript or returning it to the user, which allows you to compromise the user's interactions with a vulnerable application. So, it can range from simply popping an alert box to keyloggers, they're possible in XSS, or you could steal a user's cookies. So one specific cookie you want to steal is a session token. So essentially when you log in, you're given a session token. And if someone's able to steal this, they can impersonate you. This is actually, it's been seen quite a lot in the past with online banking. People will try to steal your session token so they can log into your, bank account. So there's three main types of XSS. Reflected is where the malicious JavaScript comes from the current HTTP request. So you might see in a URL a script tag or a reference to a particular JavaScript. So if you were to execute this URL, it would execute, if you were to request that URL, it would execute that script and the results would be sort of returned to you there. Stored is sort of where it comes from the website itself. So say you have a forum post. If you were to inject some sort of JavaScript into that forum post, every time a user visits that specific forum post, the XSS will trigger and do whatever it's been designed to do. There was an example recently where there was a self-retweeting tweet on Twitter. I don't know if anyone saw that, but that was an example of a stored XSS. So whenever you sort of clicked on the tweet, it would retweet it automatically. DOM-based XSS, it's really hard to reliably exploit, really complex to explain, but essentially, sometimes JavaScript will be executed on the client side, or you'll sort of have client side code rather than server side to reduce the load on the server. So if we can sort of edit or inject our own JavaScripts, we can sort of perform XSS on the client side specifically. So how do we actually perform XSS? So there's multiple ways. Normally we would demonstrate it using an alert box because it's, harmless and it just pops up an alert on your screen. So normally we would trigger an XSS with a HTML tag. I'm going to assume that you know what HTML tags are and how they work. So one tag in HTML is a script tag. So this essentially tells the website when it's rendering the page to execute any JavaScript between the start and end tag. So what this example code does here, it just pops an alert box with that text in the box. You can also trigger an XSS with different HTML tags. So one popular one is the image tag or the SVG tag. So normally when we're defining an image, we would supply it with a valid source, like a path to an image, for example, or a URL. But what if we were to supply it with an invalid path? Well, you can specify error behavior, which in this case is executed as JavaScript. There's multiple different sort of options. So if you supply it with a correct path, you can give it sort of on load, and then as soon as the image loads, it will pop the XSS. Or you can give it like on mouse over or on click or something like that. Different behaviors for different, sort of what you want to get out of it kind of thing. So as I mentioned before, there's several things you can do with XSS. Stealing cookies and session tokens. Local file inclusion is one of them. You can do that. You can also do remote file inclusion with XSS. And many, many more, like keylogging and stuff like that. So I'm just going to quickly show you some examples of XSS. So if we take this, let me just zoom in. So this is called XSS Game, really useful resource for learning about XSS. So often when say you're on Google, for example, and you just want to search for dog. Obviously there's no results found here, but you can see your query in the top. But what if we were to sort of try to stylize our query using HTML tags? As you can see here, it's been formatted in the way we want it to. So what this occurs because when it's sort of parsing the query, it's not sanitizing any HTML tags. So when it executes the query and renders it back to the page, it will also render these tags as normal HTML. So we can take this a step further actually. And what if we tried to inject some JavaScript to pop an alert box like this? I'm sure you can guess what's going to happen, but essentially, if you don't remember, this tells the website that the following content is JavaScript and to execute it as such. And what this does is pops an alert box with XSS in the box. So if we do this, as you can see, we've got an XSS here. Easy, right? You just insert one tag and then boom, you've got an alert box. So this is an example of reflected XSS. This won't be stored on the server. And actually there was recently, someone found one in the Google search page. It was a really complex attack, but really, really smart. And it just goes to show that, these do still exist. So if we go to the next level, so, I'm sure you've all used a forum before. where we can make a post on the forum, right? And it'll pop up as we expect it to. But what if we wanted to stylize our post? As you can see, it's been rendered with the tag we specified. So we just quickly clear the posts. So you would think that, you can just supply an alert box. But as you can see here, it's not been displayed. So sometimes websites will specifically block script tags. So something else we can do is, so we know it's allowing HTML tags. So what if we want to embed an image in our post, right? We just do this. As normal, you supply the image, you give it a URL or a path to a file. You can see it loads the image. So what if we take this one step further, give it an invalid image, specify some error behavior, and close the tag. What do you think will happen? Will it trigger or will it be blocked? My guess is it will trigger. And this is because we aren't blocking image tags, as it's like sort of in old forums you could specify HTML in your posts. So they wouldn't block something like an image tag because it's expected and valid behavior. But that's obvious that there's no image there. So if you're trying to keep this somewhere, it will be obvious that it's not what it should be and it'll probably be deleted. But what if we take that again a step further, give it a valid image, so we can do onload, and this will essentially, when the image loads, it will execute whatever's in here, which for this example is just our XSS. There you go. You've got a valid image. Now, I'm not going to show you all of these, but you can do the same thing with on click, on mouse over. There's like 1,000,001 different options for this. There's pages on Google. You can see sort of where this sort of comes from and how it can be, put to the user in various different ways. So this is an example of stored XSS, where if I was to reload the page, you'd get another alert box, because every time the image loads, it will pop that alert box. So you can sort of see how dangerous this is, because a real attacker wouldn't be popping an alert box, they'd be stealing cookies or something like that. So if we go back to the presentation, XSS, it is probably one of the most common sort of vulnerabilities in websites, but it can be prevented if you filter user input as it arrives. So as I mentioned earlier, we can sort of filter out script tags or angular brackets and stuff like that. So if we filter as strictly as possible, we can sort of prevent most simple XSS cases. If we encode the data we use on output, we can prevent it from being interpreted as active content. So a lot of the simple payloads use script tags. If a web server sees a script tag, it will execute the script tag. But if it's encoded in some way, it won't see it as active content, and therefore it won't be executed. So in HTTP, there's headers. That was covered last week with Michael. So to prevent XSS, you can use the content type or X content type options headers. So essentially what these do is tell an application what data to expect, and if it's not that data, it won't execute it. Something else you can do is, as a very last resort, you can use the content security policy, and this reduces the severity of any remaining vulnerabilities. And as Harlan mentioned earlier, if your CSP is strict enough, you can actually block pretty much every XSS. So, other types of attacks, which we haven't covered today, there are command injection. So, we mentioned earlier for SQL that it was an example of code injection. Well, command injection is sort of a similar principle where we want to execute arbitrary commands on the host of a vulnerable application, which is normally the operating system. So, say you have sort of a website which allows you to ping people. This is executing a ping command like a few layers down on the operating system or the system shell. So it's executing a ping command. If we can sort of escape that standard command, we can execute our own. So they occur mainly where an app passes unsafe user input to a system shell directly, or via well-known unsafe functions like exec or eval. I think they exist in Python, PHP, JavaScript, a load of other languages. Another type of attack is file inclusion. So this is where sort of you include unintended files for execution. So you can do this locally. So for example, we can get, password files or backups from the local system, or we can do this remotely. So if we want to sort of, get a shell on the server, but there's nowhere to upload like a file, we can remotely include that file and have it be executed, which will, trigger our shell. So Python web frameworks are sort of gaining popularity. The main one is Flask and the Jinja 2 template engine. So essentially, if you want to generate dynamic websites, generally you will use templates to do that. So every website's sort of standard. But what we can do is actually inject malicious template commands or directives. So what this does is it basically tells the template engine to, perform a specific command, whether it be just displaying something as a proof of concept, or, dumping the secrets like, API keys and stuff like that, which is obviously very bad. If you've ever accidentally uploaded an API key to GitHub, you'll know that's bad. It occurs when user input is included in the template rather than being passed in as data. So a quite new and quite exciting vulnerability is prototype pollution in JavaScript. So JavaScript is a prototype-based language. So what this means is objects are constantly reused and inherited, and these are presented in the form of prototypes, right? So what we can actually do is we can exploit this to make changes to these objects when they're, sort of inherited or reused. So often in JavaScript, you'll sort of want to merge, clone, or extend these objects, because obviously every object is different. But what if we could inject some malicious JSON in there to sort of overwrite the object? So for example, say you had a function in a class sort of validating something and it was set to false by default. What if we were merging two objects together, right? If we were to merge our malicious object into, a non-malicious standard one, we could actually overwrite the original functionality. So in this case, if we were overwriting a check for like a valid password, we would be able to bypass authentication. It's quite a complex attack and it's very new, but it's also very exciting if you want to look into it further. Hopefully my little explanation of it made sense. So some useful tips if you're attacking web apps. You always want to be checking the robots.txt file. So what that is so Google works by crawling web pages and indexing them, and it uses this file to sort of be told where it can and can't go. So often developers will want to disallow access to certain, sensitive areas or folders on the website. So they'll tell the crawler not to do this, but if we look in the robots.txt file, we can actually manually browse to it. So you might find, sensitive information in there. Always check the source code, Devs will add comments to their code to help them or future developers. They can also leave stuff like version numbers, hard-coded passwords, stuff like that in there. Another sort of underrated tip is actually to use the website normally before you try to exploit anything. If you can sort of build up an understanding of how the different building blocks fit together and how it all interacts, then you might be able to find that sort of the attack path becomes a lot clearer. And certain languages and frameworks suffer from certain vulnerabilities, so it's always good to do your research. So you can sort of guess based on file extensions what's being used, like .php is obviously PHP, .html, .aspx is like some JavaScript, not JavaScript, Microsoft stuff like that. So some useful tools. Burp Suite is great, excellent tool and deserves its own session. So that's a sort of web app security framework, allows you to mess with requests, repeat them, stuff like that. SQL Map, incredibly powerful. It's an automated SQL injection and database takeover tool, but you shouldn't rely on it. There are times, quite often, where it won't work. And unless you understand how SQL injection works, you won't be able to exploit what you're trying to exploit, especially if SQL Map won't work. Nikto and Nessus, vulnerability scanners, very powerful but prone to false positives and similar to SQL Map, shouldn't be relied upon. It's great to help your efficiency, but nothing can beat manual testing. WordPress scan, similar to Nikto and Nessus, but for WordPress specifically. Harlan mentioned in the chat, ASPX allows C# to create websites. I should remember that, but I didn't, my bad. So some resources. So OWASP, which is the Open Web App Security Project, they publish a top 10 of the greatest security risks to web apps. So that's great to sort of read and get an idea of what you should be looking for. The Web App Hackers Handbook. This was written a few years ago, but it's pretty much the go-to if you're looking to learn more about web app hacking and you like reading books. So Portswigger, the people who make Burp, they have a web security academy. It's free. There's a lot of great labs on there, mostly focused around using Burp as well, which is a great way to learn about it. So if you go to that link, you'll be able to learn more about SQL injection, XSS, and a lot more. There's like tons of labs on there. I think there's 191 to complete. Cheat sheets as well. They are openly available online for SQL injection, XSS, any sort of web app attack you can think of. Google is definitely your friend here. Most of them are on GitHub. So a little side note. Today has been a very high-level overview of SQL injection and XSS. We could have gone on for hours about each of them. So it's okay if you don't fully understand. They are hard concepts. SQL injection specifically is quite a hard concept to get your head around, especially, visualizing the underlying query and how you can exploit that. And it can also get very advanced very quickly, especially when you've got to do stuff like blind SQL injection. So the challenges for this week, you may find them more difficult than usual, and this is reflected in the points. So I think the lowest value is 30 this week. So we do encourage you all to work together, research the topics further to develop an understanding, but do remember flag sharing is against the rules. If you are working together with someone, that's great, but don't just send each other the payloads once you've figured it out. As Tom mentions, Fiddler is a nice alternative to Burp. I've never used it. I've heard of it, but I've never used it. So if you guys want to look into that, Tom vouches for it. So thank you for watching me speak for half an hour. If you've got any questions or feedback, feel free to message me on Discord. If you want to see another session on web apps or have ideas for sessions, or would like to create your own challenges, let us know on Discord. Just message a committee member. The activities are available in the usual place on the CTF website, and it'd be great if we can see you on Discord in a few minutes to have a go at some of the challenges. Thank you.